Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today to get a $20 credit and launch a new server in under a minute. And you work hard to make sure that your data is reliable and accurate, but can you say the same about the deployment of your machine learning models? The Scafos platform from Metis Machine was built to give your data scientists the end-to-end support that they need throughout the machine learning lifecycle. Scafos maximizes interoperability with your existing tools and platforms and offers real-time insights and the ability to be up and running with cloud-based production-scale infrastructure instantaneously. Request a demo today at dataengineeringpodcast.com/metis-machine to learn more about how Metis Machine is operationalizing data science. And if you're attending the Strata Data Conference in New York in September, then come say hi to Metis Machine at booth P16. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And join the discussion at dataengineeringpodcast.com/chat. Your host is Tobias Macey, and today I'm interviewing Mark Marinelli about data mastering for modern platforms. So Mark, could you start by introducing yourself?
Sure. My name is Mark Marinelli. I head product here at Tamer. I've been in the data management space for about 20 some odd years now, having cut my teeth back when multi-dimensional databases and MoLAP were a thing, and then doing a stint for quite some time in what is now the self-service data prep world. And now here at Tamer, I'm working on technologies that are really bringing machine learning and AI into the fold here as over time we've progressively gotten better at automating a lot of those data management pipelines.
And do you remember how you first got involved in the space?
Yeah, I've always been fascinated by data. Undergrad, it was computer science, and the data stuff was more interesting than the network stuff or anything else. So when I first started as a software developer, I was working on a data management platform, as I said, in the multidimensional database space back in the late 90s. And ever since, I've just been really interested in these variety of technologies that I've outlined in where the rubber meets the road, where those data actually get into people's hands, and facilitating getting useful data into people's hands as quickly as possible, as opposed to the sort of big iron ETL stuff. That's where self-service data prep, or now in this sort of modern data unification, machine learning driven thing is how quickly can we derive value from those data and get it to people so they can do their biz or their data science or whatever it is.
And so before we get too deep into the topic, can you start by sharing what your definition is of a master data set and data mastering so that we can use that to build off of?
Sure. Yeah. So data mastering, or maybe we would say at Tamer, data unification. It's a little bit broader than the loaded term of mastering, but essentially you're taking data from a variety of different systems, which are all trying to describe the same thing, the same entity, like a person or an invoice or whatever. We're taking data from across all of those systems, which were not designed to be interoperable, and unifying the data, putting them all in one place where they're aligned to a common set of attributes, where we've discovered linkage among the data, either because records are linked in some way or duplicated, and then are rendering out canonical versions of each of these things, a single view of the customer or a single view of a supplier or whatever, as what people would often call a golden record, so that the downstream analytical use cases or whatever consumption use cases are can work with the latest and greatest and most comprehensive set of each of the customers, suppliers, invoices, whatever that they need to.
And can you discuss a bit more about how that master data set or the unified data records get used within the overall processing and analytical systems within an organization?
Yeah, sure. So the attributes of a problem set where mastering is essential are where you do have a variety of different views of what's essentially the same thing. So a great example of something we see a lot is when you're trying to do customer analysis so that you can track your customer journey, do upsell, cross-sell, monetize your customers as best as you possibly can. If I've got 52 different variants of Mark Marinelli, the customer across all of my channels where I'm collecting customer data, very, very difficult for me to bring all of those data to have that unified picture so that I can say, wow, he's buying stuff more online than he used to, and that informs the way that I'm going to manage that customer. So anywhere where there's that disparity of data that are all describing the same thing, customer 360, as a lot of people would call it, is really popular. Another one, really different area of a business, but has a lot of the same attributes, would be dealing with your suppliers. If you're a big global multinational, and you are buying a lot of your components to build your hardware or software or whatever from a variety of different suppliers, those are all probably going to exist in a lot of different systems. A lot of those data that you receive from your suppliers are totally not under your control. So they're all describing the supplies that they're selling to you in different ways. It's essential for you to have a single view across all of that procurement or spend footprint, so that you know that what one person describes as completely different from someone else is actually both 8.5 by 11 inch printer paper. If I can't unify and deduplicate and master these data, then I don't know how much money I'm spending on each of these products, with each of these suppliers. So it makes it very difficult for me to do good inventory management. Enables me, once I've gotten on the other side of this, if I do have a single view of each of my suppliers, and I'm no longer treating the 15 affiliates of a supplier as 15 different suppliers, because I didn't have this visibility, but now I'm treating them as one, then I can see my aggregate spend with them is much higher than I thought it was. I should renegotiate my contract, or change my purchasing behavior. So those are a couple of examples where having the data really dispersed across the systems, bringing it all together and having a single way to treat your customers, your business partners, or whatever, is essential to getting the right analytical outcome.
And one of the upfront challenges that I was thinking about as you were discussing that is how you would sort of plan ahead to have some sort of unifying attribute that you can use to be able to create this single record of a given entity, whether it's a customer or a vendor or a particular unit of resource that you're getting from that vendor. So I'm sure that there is, in a lot of cases, some measure of manual effort involved there. But I'm curious if you can talk a bit about some of the practical issues and strategies around being able to plan ahead in either your data model or the way that you're collecting the data to make it easier to create that unified record.
Sure. Yeah, we see a variety of different techniques there. I would quibble a little bit with plan ahead, because we talk a lot about Agile mastering, and see our customers sort of embracing this. And we'll plan a little bit ahead, and we'll start with something, but know that what this unified attribute set looks like 9 months from now is not necessarily what it's going to look like 3 weeks from now, and not try to solve that entire problem a priori, but rather build on something that's a quick win. But there's a few different ways to do this. One, there are off-the-shelf schema for a lot of different entities. There's not a lot that differs for a human being from company to company. If you're treating with customers, you can get stuff like that from public websites. There's also probably somewhere in your organization already a master. You've probably already tried to solve this problem, and maybe you're struggling with it, but you've got a pretty decent definition of what a customer looks like that everybody has already started to plumb into their analytical applications. Use some subset of that, and then map all of the other data sources, which have a variety of different ways to describe those data, map all of them to that same attribute set. That itself can be really cumbersome, because you have rule sets that are doing these mappings, and then as soon as a new data set arrives, because you've got a supplier that's sending you different type of data, or you've just bought a new company and now they have a system that has all of these data. As soon as that stuff arrives, it's going to break all your rules. So you have to go back and retrofit those rules so that you can map those source data sets to that unified schema. That's actually an area where we've done a lot of research, and we've got software that can automate that, because a machine can actually figure that out pretty well and be more resilient in the face of changing data on both sides, both on the source and the destination schema, than a rule set that somebody's got to build and maintain and will constantly be behind the eight ball. So, in brief, it's finding something off the shelf that already describes the relevant entity or domain. There's out-of-the-box stuff that a lot of platforms bring you that is already encapsulating some of those end states. There's something maybe sitting around your business that is already good enough. And in any one of those scenarios, you're going to want to be able to modify that schema without incurring capital D, capital M data modeling exercise, where now we have to retrofit some entity relationship diagram or anything like that. You want to be as lightweight and agile as possible with the construction and maintenance of that attribute set.
And so when you're creating these records to canonically describe a given entity, it sounds like you want to establish the minimum number of attributes that you can possibly get away with on that record, so that you don't have this issue of the evolving data model then breaking any references to that entity from other systems.
Absolutely. It's always going to be this common subset that's just enough. I mean, I think that just sort of philosophically infuses a lot of what I'd have to say. Just get to that small, we'll say minimum viable schema that is the common subset across all of these data sets that is useful immediately for analytical or operational purposes, and then build on top of that as the community that starts to use these master data proliferates and it applies more requirements. And it's also not one size fits all. Every single one of these destination attribute sets is going to be contextual. That's for golden records. It's for just the model that you're using for the data sets. One person is going to want different things from your customer set than another. And so it's really important for you not to try to just push out one sort of, least common denominator to everybody, but have a 1-to-n relationship between your mastering logic and the way that that golden record or any of the data are surfaced to different constituents, which itself can be really tricky.
So one strategy seems like you might want to have the capability of layering additional attributes, where you have your sort of core minimum number of entities, or maybe you just have a unifying ID, and then you have other systems that are adding degrees of information, so that if somebody wants to have all of the records, they would maybe go to one interface, whereas if they want to infer their own information, they would just go to that sort of minimal set of records to be able to reduce the amount of churn at the core set, but layer in additional information as you go sort of further afield from that.
Yeah, and it's a subset of these records. It's a subset of these attributes. And sometimes it's a different connection in those records. One use case may define a common thing that we see as individuals versus households. One data set they're going to have exactly the same column set, but one of them is going to consider my father and myself as two different people, and another one's going to consider us as one household if we live together. Having each endpoint, analytical endpoint or consumer constituency, be able to impose their own model on this stuff and their own, I say rule set, but oftentimes it's a machine learning model. It pushed that control over how the data are consumed as far out to the consumers as you possibly can, which is really not the way that we've been doing this for the better part of 30 years. Instead, you sit down with the business user and they try to explain what they're looking for, and you codify their business logic in a series of ETL transformations or MDM logic or an EDW. And then you get some of it wrong because you had to make some assumptions, and then you go back to them and rinse, repeat. And that there's a really protracted cycle there where you're working on their behalf. And a lot of this, the modern tool set allows these individuals to have a bit more agency over how the data are mastered and consumed. That's the best way to do it. Of course, that has governance implications to make sure that not every single individual is going off, creating their own view. But there are ways to balance that need for autonomy versus the chaos that can ensue if everybody's looking at things entirely differently.
And so when I first said the plan ahead, and you took issue with that and what you're describing here of this sort of waterfall process of defining the master schema and the way that this information is going to be codified and captured, and contrasting that with the more agile methodology that you're promoting and that's become more popular in software engineering as well, I'm curious, what about the current landscape of both businesses and the technology platforms that they're running on top of makes that waterfall approach impractical and enables us to move towards this more agile approach to managing these golden records?
Well, a tough one for any waterfall environment is the shifting sands of data, and so much data is being collected now. A lot of it externally to companies where they have no control over the format and quality of those data. The speed with which data are arriving, the variety of formats in which these data need to be assimilated so that businesses can leverage all of these data for their competitive advantage or whatever their analytical use cases are, that just breaks. You can't wait 2 months for someone to incorporate a data set that may be ephemeral, and you can't have to bring in your data engineering staff every time a new data set arrives that's a little bit or maybe appreciably different from the stuff that you've seen before. So I think that the industry has focused a lot of its fire in the last couple of years, a decade, let's say, on solving the volume problem. Big data, Hadoop, Spark, that's all wonderful. Not so much on the variety problem or applying as much automation and simplicity to that. So there are areas where waterfall, I think, is just fine. If you've got a credit card processing transaction ETL pipeline that's just humming along and those data aren't going to, the format of those data aren't going to change all that much, then fine. Do a yearly release of your update of that platform. But when you're trying to be really nimble and constantly accumulate new data and validate whether those data are even useful, if you have to stand up a multi-month or a year-long project where you don't even know if it's cost justified to do it because you're not sure if these data are useful, you're just not going to do it.
And so for somebody who is trying to move toward having a centralized sort of master set of records for being able to model these entities that are important to their business, if they don't already have a system in place to be able to capture and integrate that information, and they don't want to get caught in this trap of having this multi-month or multi-year project to build it up, what are some of the steps that they can take to move toward having that capability without having to do a sort of stop the world approach of not doing any other feature development or halting other projects, where they can just sort of integrate this into their existing workflows?
Yeah, I think there's kind of 3 different layers to adopting an agile approach. One of them is mindset. Agile mindset. Everybody in the organization needs to be okay with some of the risk of doing things faster and maybe not as completely as they would in a waterfall project, knowing that they're going to realize immediate or short-term benefit that is going to be important to their business. So there are certain areas where waterfall is the way to go. I'm happy that the people who build large commercial airplanes are not doing testing an MVP on me as a passenger, and they took this approach. And so there are things in data management where the accuracy of those data has to be so complete and trustworthy that you may build in a lot of these checks and a lot of the big iron scaffolding. There are other areas where if, let's say we're going to run a marketing campaign for our customers, and if I received the wrong mailer that was intended to someone else because they got my golden record wrong or they incorrectly mastered me, so what? If that's happening 2% of the time, but in order to get the system stood up in 6 weeks and do something productive, we had to cut that corner. Everybody's got to be okay with that, or at least judicious in how they take on projects with this agile mindset, so they know where agility and probabilistic and potentially a little bit incorrect outcomes are acceptable versus the other stuff that needs more rigor. So there's a mindset component. That's the most important thing. Then there's a skill set component where, as you're starting to do this work, make sure that you've got these squads of folks where you have the consumers of the data, the data engineers, the brokers of these data from these systems, all working very closely together in as close to a sort of agile Scrum methodology as you could get, in rapid iterations, collaboratively working together to build up incrementally. And then the last component, mindset, skill set, is tool set. You can have a wonderful mindset and want to adopt all of this agility and be open to it. But if you're using legacy systems that really cannot adapt, cannot introduce new functionality easily, you're just not going to get anywhere. So we at Tamer definitely have been proponents of what we call a data ops approach to this, where instead of taking one monolithic tool that supplies the entire data supply chain from raw data out through this analytical ready data, instead just know from the beginning that you should be pulling together a suite of interoperable technologies that are best of breed. Each one of them is going to contribute the best of breed. One will be the best of breed for mastering, another will be the best of breed for cataloging, another one for governance, and layer those capabilities on, because you don't have to get all of them working in their fullness before any useful data drips out the other side. So if you start with a small mastering project with technologies like our own, and I'll put in a plug for Tamer, where we can get very far very quickly, because we're offloading a lot of the historical data modeling and rules creation onto machine learning models, so we can get there really quickly. If you take on something, take in all of your customer data, start doing interesting things with the customer data where your risk profile's okay, and then layer in another technology for cataloging these data now that you've built a lot of these relationships and a lot of this metadata, and then layer in something for governance so that you have controlled consumption and controlled access to these data. Just don't try to take it on all at once, and make sure that the tools that you choose are each very interoperable with the others. It's got to be very API first design. You're going to have to do some work to stitch them together, but you don't have to do it all up front. And the benefit of layering this stuff in and keeping it disaggregated and decoupled is that if somebody comes along and builds a better mousetrap for any one of these components, toss your existing one out, throw the other one in with minimal disruption.
And is there a particular size or scale of a company or project at which there's a tipping point where it makes sense to start building the master data set? Or do you think that it's something that anybody at any scale can start integrating into their platform?
The latter. If you've got more than one platform or one data set that contains overlapping or similar data, you've got to do mastering. And that's so that the important thing is to make it economical for people to be able to do mastering at small scale, and not only when you've already got 14 ERP systems that you've got to stitch together, but a Salesforce instance or two Salesforce instances and some CRM data that you've got in some on-prem database, you should be mastering.
And so one of the things that you were discussing as far as being able to accelerate and simplify the efforts of building this master data set is integrating machine learning and artificial intelligence methods. And I'm curious what you have found to be the limitations of that approach for merging the data sets, and where it's necessary to have human intervention for being able to build up these catalogs.
So in reverse order, the human intervention is a feature, not a bug, in that with the machine learning approaches we see, it's supervised machine learning. It's really the machine needs to learn from the human understanding of the data. Where the machine is exceedingly helpful is that it learns pretty quickly, and in over a few iterations of training and correcting for some of the suggestions that the machine learning provides, you can get something very robust and trustworthy versus the sort of long process of codifying the rule set that would be an alternative to these model-based approaches. The limitation to that is that if a human being can't figure out if two records belong together, or a human being can't figure out certain things about how these golden records should be constructed, a model is not going to be able to figure it out either. So there needs to be some baseline of recognizable attributes and structure to the data that in sort of data science terms, you may have to do some feature engineering and feature extraction. So if a bunch of unstructured data comes in, you may have to turn that into some attributes on the data that can be recognized both by the humans and the machines. So there's oftentimes some pre-processing work and transformation necessary to make it human ready and machine ready. And if that's not the case, rule sets aren't really going to get to that far either. But I definitely say that at this point, it's a supervised machine learning approach, not a completely unsupervised. Just give the model your data and it's going to figure it out. It's still supervised and thus is predicated on a human's ability to make these distinctions, and then the machine can do it at scale.
And do you think that it's practical for somebody to build up their own AI models on their own data sets? Or do you think that you at Tamer and similar companies have the advantage of being able to run these models against multiple customers' data for being able to determine what some common approaches and common formats of some of these attributes are for being able to more intelligently merge these disparate data sets?
Yeah, that's a great question, and it's one that we get from our customers and prospects all the time. I just hired 50 data scientists from the best programs in the country. These algorithms are well understood, 20 years old now on some of this stuff. So I'm just going to do this myself. My reaction to that is that there's a few different aspects of a product that does this that are going to be superior to a project that does this. You're going to stand up a project, you get your big brain data scientists to go and apply some of these models, and we've seen it. Then they move on to the next project, new data arrives, and it perturbs the model, or the model degrades for some other reason. Where are they now? Okay, we're going to bring them back off of that project, and they're going to hopefully remember what they did in this thing and have really good development practices so they can quickly update the model. But we're going to be sort of single-threaded through them because it is only on our behalf as data consumers that the data scientists were able to build this model. Better would be a product that allows direct contribution to the upkeep and the quality of those models and the continual training of those models from the people who are consuming the data. So one aspect of product versus project is the way that you continually solicit the training that you need to keep those models trustworthy. Another is stitching what you've done in with the rest of your ecosystem of platforms, as I was describing before. How do we get plugged into our catalog? How do we get plugged into our governance platform? And how do we get plugged into Tableau or Click? Having a project build APIs and interoperability and the right layer of connectivity, that's something that most folks are just not going to take on because they just want to get it done, and they're not thinking of this as a general purpose component within their data landscape. So there's another one where product is going to be superior there. And the last is just the particular ensemble of models or algorithms in the model that make these models accurate and also computationally acceptable. We've got a lot of compute out there, but these are really n-squared or very, very computationally expensive practices. And there are ways that you can pull together the sequence of processing and ways that you can constrain the problem that can actually be a far more acceptable compute footprint, give things like real-time or low latency response. That's something where I'd rather be working with a company that's been doing this for many years across dozens of customers than stubbing my toe trying to figure that out myself as a data scientist or a data engineer.
And in terms of the Golden Master data set, once it's been created, what have you found to be some of the limitations there in terms of being able to integrate it with other analytical systems, or issues with being able to create a canonical entity for a particular problem domain?
Yeah, that's it can be kind of tricky because there's an area where it's always going to be contextual, and as if it's fluid at the same time, if the contributions to that golden record are changing on a near real-time basis, or with any frequency, the folks who are consuming these golden records need to know that. They need to know, and they need some agency over that. They need to be able to say, freeze this golden record, so that even as new data arrive and the underlying rules may suggest that a different record is going to contribute an address to this record, I don't want it right now. I know that's the more current record, but I don't want that right now because I needed to sort of freeze things as they were. I also need to know some of the history of how we got here when these things change. Let's say I didn't freeze it, but I need to know the sort of lineage of how this golden record has changed over time, because in my context, that may be really, really important in of its own. So I think the way to answer your question is that it's essential for golden records, the construction of golden records, the mechanism by which they're built, and the tools by which they are maintained, to be really transparent in all of the underpinnings of how this stuff is done, and to have both a concrete and user configurable survivorship capability, but just giving all of the information, all the context that allows the consumers to set the right rules, and to make sure that they're not working with data that are stale, and unless they want to.
And that brings me to another question that I had in terms of maintaining the historical context of a record as it does evolve. Are there practices or platforms that you have worked with that allow for easy versioning of that data, so that you can, for instance, go back in time if you need to rerun a historical analysis to say, this customer's address at X point in time was in Nevada versus where they are now in Virginia, for instance?
Sure. Yeah, there are both implicit and explicit ways to do that. Implicitly, to just keep versioning the data as new data arrive, and anything changes, the deltas from one golden record to another, or from one cluster of records to another. You do that implicitly and provide that to people. But you also want to provide some explicit versioning and tagging, so that folks, as I said, can freeze this thing, or to say, I want to publish these golden records right now, or I want to publish this rule set, and have that be the development rule set, and have a different rule set be the production rule set. There needs to be a lot of configurability around how this stuff is done. And there's absolutely tools increasingly that are providing more of this end user friendly management of this stuff. Catalogs also help a ton in retaining and making very useful a lot of this metadata around lineage and history of data, graphically and in other ways, where people can really intuitively figure out what the life cycle of these data components are, and how they can traverse back to a different time when the data were more relevant or better for whatever their purpose is. Again, it's just, there's so many different, in any business, there's so many different constituents for these data that each want a different thing, that you need pretty good workflow and collaboration and configurability around how each of them is going to get what they want. Otherwise, they're going to take a snapshot, they're going to put it in Excel, and now they've stranded this data off. It's never going to get better, and that's the last thing that we want people doing. Just lower the friction for somebody getting what they want in that point of time, with all of the context they need to interpret it properly.
And when it comes to the storage of the master records, is there a common sort of platform type? Is it generally just a relational database system, or is the way that the information is stored as diverse as the people who are using it based on whatever they're using it for?
I see more of the latter these days, to publish these data sets out into a lake, because there are going to be myriad different data sets and myriad consumers of them. On the other side of these data sets is one group that's using Tableau and another group that's using Power BI, and they're doing totally different things with the data. Trying to to push them back into an RDBMS, at least these final golden record data sets can be kind of overly expensive, and you run the risk of trying to conform everyone to a single least common denominator set of records rather than having the diversity of outputs that's necessary to support a diversity of use cases. But as you're doing this work, there's a great forensic outcome of this. As you're building these golden records and you're deduplicating and clustering all of these records together, you're going to find out that some of these sources are of relative poor quality. You can do upstream correction in those data sources and backfill them with some of the information that came out of the golden record, affiliate them, these clusters of records across different data sets by applying a new ID that this process of mastering has defined or derived from the data, so that people can do these federated queries across the data sets. So there's also ways to retrofit the source systems from where this stuff comes with the information that you've gained in the process and make them more useful as well. But I do see more of it being pumped out as analytical data sets in a lake for, as I said, just myriad different use cases downstream.
Yeah, and one of the other questions I had that partially answers is how you manage the subsequent integration of the master records with the rest of your data sets, particularly when trying to reduce latency issues by having to call out from multiple systems all to this central location, whereas if it's all in the lake, then there's a higher probability that it'll be more directly integrated into the existing data.
Yeah, it's important that any interoperability between a mastering system and the rest of those systems not only supports incremental and sort of bulk processing, but also low latency processing. When you want to apply the golden record in real time, if you say, a great example of this would be, I'm in Salesforce and I'm about to enter a new customer record. I should be able to hit my mastering system and maybe some another system in real time so that I can return the existing potential match for this data and surface to that user, hey, are you sure you want to enter another Mark Marinelli? Because I've already got 14 of them in here, and this what you were about to enter looks an awful lot like that. That's it satisfies a set of requirements that can surface an entirely different set of use cases when you can leverage these data in not just in the analytical consumption of these data, but in preventing the production of more bad data that you end up having to master. So I think it's just it's really important for all of these systems to be able to support the real time application of mastering or whatever they contribute to that whole supply chain to the data.
And in terms of the security and auditing and access control concerns for the master records, do you think that it should be a step above what's implemented for the rest of the data platform, or do you think that it should be treated as homogeneously as the rest of your systems and not have to constrain access or capacity for those instances?
Yeah, governance is it's tough. It's sort of a tax you have to pay. We want to make sure that not everyone is, we certainly want to make sure that no one is making bad rules about how to construct our golden records or do our mastering or anything like that. So there need to be some countermeasures against mistakes that will end up causing bad downstream data. But that needs to be balanced against wanting tens or hundreds of people to participate in the construction and curation of the rule sets that we use to build all of these outcomes. I don't have a hard and fast rule from our experience there, but just say it really based on use case, based on the folks who are working on the data, some degree of governance is going to have to be applied, but just make sure that that the governance doesn't get in your way. It should be collaborate first, govern later, rather than govern first, and then hope that people are going to be able to collaborate. It's important, and as I said, it's a tax that you pay on any of this work. But you just have to make sure that for the vast majority of use cases where governance is not going to be as as necessary, that you're not applying the same governance regime that you would have for, say, sensitive patient data to something about a marketing campaign for doctors, let's say, if you're in a healthcare domain.
And for cases where you have worked with companies and individuals who are trying to build a system and a process for creating and managing these master data sets, what have you found to be some of the most common stumbling blocks that they come up against?
The biggest thing is not getting quick wins. Because so many of these legacy platforms and legacy approaches adhere to a waterfall model, and everybody gets together, the steering committee meets, we list out our most valuable data sets, we start building this infrastructure, and then months and months and months go by before any useful data comes out. That's where people just start to fall off. They're all right, well, this is potentially going to be a white elephant. I'm not getting any value from this thing yet. I'm going to stop showing up at the steering committee meetings, or we're going to start forking off our own mastering or somewhat adjacent to mastering capability, and instead of waiting for the big public works project to get us what we need. And that's how these things fail. And they often do fail before they can recognize any value, or certainly not the ROI on what is oftentimes a resource intensive and expensive project. Quick wins are the way to stop that from happening, to pick small problems that are still valuable in measured in time span of weeks, be able to produce something useful, and then build on that, and then go adjacent into another domain using the technologies and the techniques that you've learned from the first one, and score a quick win there. And then over time, you can take on some of the more strategic but maybe harder problems. But it's really just keeping everybody in the boat, showing as quickly and as frequently as possible the value that they can derive from the mastering process.
And are there any particular references or resources that you recommend people look at when they're starting on the path of building these master data sets or the systems to manage them, either from the theoretical or practical aspects?
Yeah, certainly. I mean, there's great organizations like TDWI that really sit on top of a lot of great information and industry expertise. They have shows and a lot of publications. That's one. The vendors themselves, all of us that are software vendors of any of this stuff, big or small, will have good stuff on our websites about the variety of different techniques and the value in attaining these. And I'd go to any one of these vendors' solutions page and read some of the case studies there and say, wow, all right, this case study from one of their customers said that they were able to get on top of their supplier management in the span of a few months. That sounds like me. I want to do that. Even if that's not the vendor you go with, there's just a lot of sort of general purpose thought leadership information about how to apply the techniques of mastering to your data for quick benefit and huge benefit. Millions and millions and millions of dollars here can be saved by having better, cleaner, more accessible data, and doing so without an army of data engineers to build the infrastructure to support it.
And are there any other aspects of data mastering or applying machine learning to this problem domain, or anything else along those lines that we didn't cover yet that you think we should discuss before we close out the show?
Yeah, I think it's important as we talk to the market and we talk to prospective customers and our customers, there's a lot of skepticism remaining on AI and ML, partially because the term machine learning has been so diluted by a lot of marketing, where everybody wants to have some machine learning in their technology, and then people see what they mean by machine learning, and they don't really mean machine learning models. On the other side, there's really sophisticated machine learning or AI platforms, and people have been so inculcated with a rules-based deterministic approach to solving this problem that they look at that and that's magic. There's no way that could possibly work. I mean, how could you do this in a tenth of the time that I'm doing this now? I really hope that people are willing to give it a shot with some of these approaches and try it out. It's not hard to do this, and you can experiment, and we just need sort of generationally, I think right now with the folks in the data ops ops and IT departments to embrace this as a better, faster, cheaper alternative to the ways that we've been working before, to understand that there are conditions under which those legacy platforms and approaches are superior, but really to just to lean in to this new breed of technologies. And very quickly, once you started working with one of these tools or approaches, you'll say, oh, well, that's not magic at all. Now I understand how this works, and I understand its limitations, but I also understand its superiority. That's just what I'd hope everyone will, rather than just reading about it, will try to dive in and stand up some of a project and realize these benefits without, realize these benefits as quickly and as fail fastly as possible. Otherwise, the alternative is the opportunity cost of doing what you're doing with some of these legacy technologies is really high.
Right. So for anybody who wants to follow the work that you're up to or get in touch, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Oh, I really think the biggest gap is in the ability for the consumers of these data to influence the quality of that data. You build this big infrastructure and out comes data, and then somebody starts working with it and in, let's say, in Tableau, and they say, wow, this is wrong. I think there's a problem here. How do they get that feedback to someone who can do something about it? There are ways to do this, right? Drop an email to whoever brokered these data and hope that they're going to fix it. In the Sky Blue future, while you're sitting in that tool, you should be able to say, flag something as being wrong, flag a record or a column as being wrong, and have that be fed into potentially fed into the rule set or the machine learning model that's producing these data to make it better, as training data in a model. At least have it enter into a structured sort of backlog for your data engineers and IT professionals to go through and remediate. I think that's the biggest thing right now. We're getting better at producing pretty good data, but we haven't gotten much better incorporating when things are broken systemically or systematically into making those data better. That feedback loop, I haven't seen much of it, and that's really, as I said, the Sky Blue future for all of us.
All right. Well, thank you very much for taking the time today to talk about the problems and approaches towards managing master data sets. It's definitely an important issue, and so I appreciate that, and thank you for taking the time, and I hope you enjoy the rest of your day.
Thank you very much. Appreciate you having me on. Take care.